Hey everyone there, it's Blake Hooper here and I'm joined with Bernhard Schultz. He's the Chief Research Officer from the Fantom Foundation. Thanks for coming on.
Thanks, Blake. Thanks for having me.
Perfect. So today I wanted to sort of broach a few questions, understand a little bit about Sonic, what your involvement is there, and also what everyone's looking forward to it, but what to expect. So let's dive into it with a little bit of your background first, and let us know where you come from, some of your credentials, and then we can kick off from there.
Yeah, sure. Well, I have been working for the university here at the University of Sydney in Australia for some time. My speciality or my research is centered around programming languages and systems work, and I have also done several leaves from the university working for industrial research labs, specifically for Sun Microsystems and Oracle Labs. And here the main topics were about security of system code and Java programs. And the last few years, with the rise of blockchain technology, my research team and we were very interested in programming blockchains, and this was sort of a very natural transition to take again leave from the university and work now for Fantom on blockchain technology.
Perfect. And you did mention a little bit of Silicon Valley in there as well when we were discussing earlier.
Yeah.
So we don't want to leave that out because everyone wants to hear that sort of stuff. Buzzwords like Silicon Valley, they do definitely put a little bit of, everyone wants to see that sort of stuff. So I'd like to sort of jump in a little bit, understand a little bit about what has gone on in the background to building Sonic, and some of the technical things that you guys have been focusing on. So if we sort of start off with, the transition, and my understanding, and you're an expert in that client space, as you've mentioned to me, my understanding is, so Opera is the current client for Fantom, and now we're moving to Sonic. So what does that mean in general terms for people that are watching?
So Sonic is really a substantial improvement of Fantom's network. So the network is run by nodes, and the nodes need very specific software called clients, and these clients have several parts. And so one part would be consensus, making sure that transactions which come in are ordered in the same way among other nodes. Then there's a network layer, communication between nodes. There is a block processing component which has a database and a virtual machine, and all these components together form the client, and this ensures that a blockchain can be hosted and works as it should work. The problem with current blockchains, especially L1 blockchain, is that they are slow.
Yeah,
and
we've noticed.
and the slow in terms of throughput. This means how many transactions they can really process, and also the other important number is how long it takes to settle a transaction. So the time when you submit a transaction to the network, and then when it shows up on the ledger in the network. So this time to finality, it's called.
Yes.
That's really an important time for measuring the speed of a blockchain. And Go Opera was already very fast in terms of time to finality. So we had really seconds. So it was quite competitive, or as it is, it's quite competitive. But the throughput was sort of limited to 30 transactions per second, and we wanted to substantially improve this.
Okay.
And this is now the new Sonic technology.
So we've effectively improved Sonic, the transaction throughput at this point to now take it from 30 to what I saw the other day. Sometimes we're getting up to like, was it 8,000 I saw?
Or 10,000. So
Yeah.
the problem is that transactions per second is a very rough way of describing the throughput of a system, because a transaction is not equal a transaction.
Of course.
So there are some transactions which are cheap and fast, like moving money from an account to another account.
Yep.
And other transactions involve smart contracts, which will take, of course, much more time than just transferring money. So we measure this in form of gas.
Okay.
And so some transactions have low gas consumption and other transactions have very high gas consumption. And when we are talking about these transactions per second, we play around the gas complexity per transaction. The initial experiment, we announced this last year around November, October, was 2,000 transactions per second. And here the idea is that we used the average complexity of a transaction from the Fantom mainnet, which was around 210,000 gas.
Great. Yeah. Well, that's interesting, because if I'm just doing the quick math in my head, that's about 100 times faster. Doing the same transaction mix that you're seeing on the network, and then we're looking at going 100, 2,000, that'll be 3,000, but let's just call it 2,000. We're talking about improving on that by about 100 times.
So now you have these games you can play. So you can basically lower the transaction complexity, and for most transactions you may not need this complexity. So for example, for ERC, small ERC trades, the ERC20 trades, then you can get it up to a substantial number.
Yep.
But there is also a problem in the industry, so there is a lack of benchmarking. So everyone announces huge transaction numbers, but at the end of the day we would need benchmarks which really are executed equally under the same conditions for all blockchains, to get really a better understanding, to compare, for example, different blockchains. This is not an outrageous idea. So the database community have done this some time ago with very standardized ways of measuring the speed of databases, for example, and that was very successful for the industry at large, because with these standards suddenly consumers of these databases could compare in a much
apples
more
for apples sort of things.
Yeah.
Okay, yeah. So I get what you're saying. You're sort of saying that it ranges on how people are executing or how people are measuring these executed transactions, and people can sort of fluff that up a little bit. But what we're seeing in any test that I did on Sonic in that initial test phase was just that timed finality and how quickly the slowest thing was MetaMask popping up on my screen. So we've just been like super impressed. And you're saying ERC here, we're Equalizer, we're the DEX people. Yeah. So you tell me that you can do an ERC20 transaction fast, and everyone's listening, right? Yeah. So I think that in itself is a really, really good thing, because that's what we're processing a lot of currently on the network. And if we can minimize that gas, which is what you're saying, I'm thinking the users, which are already paying peanuts for in gas, are going to pay even less to do transactions on Sonic, from what you're saying.
Well, that needs to be decided, but in general, because the technology is so much faster now with the same hardware, naturally it will lead to cheaper transaction.
If we can get enough in a block.
But, yeah.
Obviously, we have to fund the network, so the network has to pay the validators. So anyone that was sort of listening here to that node section there, and you being the expert on clients, and my little understanding is that they're like your RPCs, right? So those people there are those validators that are housing the software, which we're going to talk about in a second, how lightweight it is. But those people housing it, those validators that have staked their FTM, they're the ones that are processing the transactions or holding those clients or nodes as you're referring to.
Yes, so Fantom has validators. You can think of these are the custodian of the network. We need them to ensure that the blockchain is working. And for them, the Sonic upgrade will be a relief because we have a new database. So what this means is that this new database does live pruning. So the problem is with this is now very technical, but the problem is that we need to keep the world states in the current database for technical reasons. There is a data structure called Merkle-Patricia tries, and this keeps several states of the database of the blockchain on disk, and it grows over time, and then in certain intervals the validators need to do a spring clean. So they need to stop the validator, may spin up a second instance. There are operational risks doing the spring clean, so something can go wrong. They might lose their stake. And so for validators, these are really big news that live pruning will be supported by this new Sonic client, so that this offline pruning, switching off the validator, doing the spring cleaning, switching it on again, all this will fall away with the upgrade.
And whenever my wife mentions spring cleaning, I'm running. So these validators are going to be extremely excited, aren't they?
Yeah.
So effectively, no spring cleaning for these validators, live pruning. Now it can be run on a much smaller device, so the cost to run it is going to be less for from a device standpoint, but also electricity standpoint.
That is correct. So besides the live pruning, which is a big thing for the validators, the other big advantage is that much less storage is consumed for validators. So storage in terms of disk sizes, smaller disk sizes will be needed. Okay. And that will also make the network cheaper if the hardware required for running the network will be smaller.
Cost. Yeah. 100%. So now we're talking about really being able to power this network on minimal computing power, which is sort of the opposite to what Bitcoin has been doing. So I think some alarm bells are clicking for me at some of the advantages that are going to go on here. So and I've been sort of looking into this for a little while. So it's good to have this chat and sort of get an understanding on the technical aspects that we're going to see in the background. One of the other things you mentioned to me earlier, which was around how the network in itself will allow live pruning because it's not able to be rewound. Everything is because of the finality, and we do this by I'll let you continue because I'm going to lose it there. But
well, so it's a technical aspect of how we represent data in this new database, storing the state of these blocks. And the old version, or what is currently used in Go Opera, keeps versions of, or you can say the state of blocks stored, and accumulates this over time, whereas the new database, what it's doing, it's overriding the previous state automatically without any kind of keeping the previous states for validators. For archive nodes, which you can see them, there's a different role of nodes in the network. They're more there as the librarians, you can say, as checking historical states of the database. They are used for the RPC interfaces. When you want to query something about the past, you have an RPC API where you can fire off, give me the log of this and that transaction. And for this kind of interface, you need archive nodes which have the full state over the whole range of blocks in the blockchain, in the chain. And for this, you need a different database. So we have in this new design 2 specialized databases. So one specifically for validators, and the other one is
something that you are sort of running as
for archive nodes. So basically, instead of having a single database serving for a validator and the archive node, we split this into 2 different databases. So we have a dedicated database for validators, and then also archive nodes have a specific database. And this kind of specialization approach is very standard, but allows us really to fully optimize the data layout, the internals of these data structures to make the storage of data very efficient and fast.
Okay, so yeah, we're just seeing improvements everywhere along the chain, and I suppose we'll go to the next point, which is what a lot of people want to see, and they want to see like how's this comparing to other layer ones. So how's this? What are the little improvements that we have that are now going to take this to the level? Because obviously Ethereum, whilst we all love it, it's a little bit of a it's not a fast system to run. It's very expensive to operate on. That's a personal experience, an experience that most people have. It's no surprise or secret. But what are the advantages that you see with all the software that you guys have developed? What's going to give Fantom the edge in this layer 1 market?
So everyone has a certain niche in this market, as you say, and our niche is really that we want to have very low time to finality, low cost.
Yep.
And from Go Opera, we can say we had maybe not so high transaction throughput, but we changed this now to high transaction throughput. So our niche is low cost in terms of transactions, low time to finality, and now with Sonic, high transaction throughput. So we want to really compete with a classical L1 setup with latest changes in the market where, the L2s sort of try to mitigate the gap between very slow L1s like Ethereum with
by running a layer, like a roll up to it.
Roll up to it, yes.
Yeah,
exactly.
okay. All right, so we're going to eliminate that on Fantom by effectively having this time to finality that's super fast, but increasing the throughput, because that has been, like, these blockchains in general have sort of been choked for so long. And we talk about going from 30 transactions to, 2,000, and that, just basically taking the same transaction like levels that we're doing on Fantom. And already we're going, wow, this is just leaps and bounds faster. So it then opens, or to me it says it opens up even new markets that we're probably not aware of, you and I. So I think, high frequency trading, that type of thing. Is there anything that sort of you've thought, that might fit well within our software? Because we build it, and now people are going to find applications, and we're going to be amazed at the applications they're finding on Fantom.
Well, you may want to talk to our business director on this topic, but there are clearly new markets which can open up with this new technology, because we have now this low time to finality and this high throughput. So arbitrage games might be possible, high frequency trading, computer games, or personal banking, banking large scale.
Okay.
That is all in reach with that new technology.
It's almost like an XRP sort of style.
Yeah. But again, I'm not the expert. I can talk more about the technology and how it's working. So for this, you may really want to ask
us with the marketing? No, 100%. But it's good to hear that there's all these applications and the technology's there to build it. Then it's the foundation's job from the marketing perspective, and then also the people that are using it to bring new users and see it. So I'm super excited because I'm going, well, we're getting all of these technology upgrades. The thing that builders like myself are thinking, and normal network or standard network users are probably thinking, is what are we to expect? So we're operating our DAP. We're connecting currently through probably Rabby, some people MetaMask. At the moment, we go to the Sonic RPC. To the Opera RPC. Soon we'll connect to the Sonic RPC. We'll do our transactions. We won't need to upgrade any of the apps, so to speak. What would we expect?
So for the end user, hopefully there will be no interruption in their current business. So the idea of Sonic is that it is a smooth rollout. So we had several decisions last year. We had to make several decisions last year related to which kind of database technology should be used for the rollout. And so we tested 5 different versions of the database, and some of them are not compatible. So which would require really a hard fork, and that would cause quite a little bit of issues for the whole network, how to do a hard fork smoothly. I mean, there are in the industry examples where hard forks went very smoothly, but others may not so successful. But beside this, we wanted full compatibility with that new technology. And so it was a little bit of a compromise in terms of speed and compatibility. And we think we struck now the right balance with the latest incarnation of the database technology. We call it the S5 schema, and that will show up in the release in April.
I didn't think we were going to go there yet. But that's the plan, I suppose. Okay.
So this is. I mean, it was not easy achieving this the compatibility to the mainnet without requiring a hard fork, and getting the speed necessary for what we wanted to achieve.
Okay, that to me that's music to ears. Firstly, you're saying April. We're not holding anyone to anything, but April would be fantastic. I'm not sure that the charts have time to adjust because April's so close. But so I'm really excited about that. I love all of the updates that you're bringing. For a builder, being able to just plug in, not really have a change, and we just go to Sonic and we just basically get supersonic performance. That's what we're gonna find from that change. That is music to our ears, right? Because hard fork, geez, that, and not only that, the users as well. Like any of our sort of community or whoever's using our products, it's a lot of work if we've got to migrate tokens and all sorts of stuff like that. So it's great to hear that it's going to be so simple to transition across. I suppose there's probably some other technical things that we haven't quite encountered, but or sort of run through here. But what other things come to mind that would be good for people to understand about Sonic moving forward?
So Sonic is really several components of the client have been upgraded. So we talked a little bit about the database. That was a really major upgrade and was really fundamental for the speed what we see now in the demos. We have an open demo and a closed demo. We mentioned this before. But other components are the virtual machines. So really this is the engine which runs then the smart contracts on the blockchain. And we made changes to the virtual machine. So we wanted to achieve here again compatibility to the EVM. So the idea is that Solidity and EVM is an industry standard. So you can't really deny this. So a huge number of D apps are written in Solidity and EVM. and we wanted to accommodate for this very huge market, so that people can really just redeploy applications on Fantom or develop new applications with the standard tools, which are available. And but we wanted to make it super fast, and so we, instead of proposing a complete new way, like for example Solana, they have a Rust machine running their smart contracts. We didn't want to be so
restrictive.
Not restrictive. I would say adventurous. We wanted to really ensure that everyone can run their applications. So the idea we had was, we have a new virtual machine, but what we do is, in the client, we have a translation mechanism.
Okay.
And this translation mechanism, how it's working is, it translates the EVM bytecode to the format of the new virtual machine on the fly. So we have a virtual machine which is different to the EVM and is better in terms of performance, but this translation helps us then to bridge this gap between maybe the not so fast EVM implementations and new virtual machines which may give better performance.
Okay.
And this translation mechanism, this on the fly translation mechanism in the clients, give us the leg up in terms of performance.
Wow. Okay. So this is, and I think you touched on something very important. The industry standard, I think we'd all have to agree, is Solidity. All right. So there's some Viper and stuff like that, but people are coding in Solidity. That's the industry standard. So I think maintaining that structure is huge for the development of a competing layer one that's obviously looking to shake the market around a little bit.
I think that's correct. So in the sense that these programming language tools take enormous effort to build. We are talking here about many person years, and a small, it can't be done by, it needs a concerted effort of the whole community building these tools. And so we can't do it by a single chain. It needs to be an industry-wide sort of effort building these tools. Ethereum spearheaded it, but other chains use that as well, of course. So it's a big momentum having these kind of programming tools for a single language, and going it a new way is adventurous and
potentially limiting in some ways, I'd imagine.
And because you may run out of in terms of person power to really deliver good tooling, reliable tooling for your DApp developers.
And I would go as far as to say, if you were trying to compete in the L1 market and you wanted to bring something new to it, very, very difficult, adventurous as you're saying, but then that would be the place where you might want to go out and try something different. Coming, from where you've already got developers that are developing in Solidity, you're already using the EVM. I think it's a very smart choice to maintain that, because to bring up anything else would be detrimental, because you've built yourself a customer base, so to speak, or a user base, and to then make some changes, you've got to attract a new one, and then you're sort of limiting the people that you're already engaged with. So I think that's huge in itself to maintain the industry standard of Solidity. From what I'm seeing, I'm just seeing lots and lots of pluses, and I think until we actually feel it and touch it, even just doing that test was like, wow, this is what I'm in for. And we are noticing that the L2s can be pretty fast to transact, but I think you lack some security across that sort of stuff. That's the difference, where with the L1 you're not getting that speed of the roll up until now.
Yeah. I mean, I just want to stress this effort, this Sonic effort was a huge effort. I mean, we have been working here nearly now 2 years on this, and this doesn't come from, from 2-3 months of work. There is a huge team behind me.
Yeah.
We have amazing people in the industry, but also people who join from other industries, from industries outside of the blockchain. We're talking about Microsoft, SAP, and
Yeah.
they bring in very specific knowledge, like how to build a database. So we have people from SAP bringing in that knowledge. We have people from Google bringing in distributed system knowledge. So we have quite a wide range of people in our technical team, amazing people who really push this new technology, and hopefully with that we can really show that we have a true impact in the industry.
From the conversations we've had, and Bernhard and I have had a few conversations to understand the system. This isn't just our first catch-up, but you have spoken very highly of these people and the level of talent that Fantom has, and I can say it from what you've said, is huge, right? And it's probably underestimated how much talent is within this blockchain team, from my understanding in speaking to you, because we've effectively got a small industry in its infancy. We've got software that's developing at a rapid rate, but there's not a huge resource of people, like you're saying, to pull on for expertise. So when you come and bring someone from Microsoft or SAP, and the biggest names within the world in the software industry as we knew it, we're now starting to see that we're at the cutting edge of having some of the best developers work on what everyone's going to enjoy as Sonic on Fantom.
Yes, I mean, that was really an amazing experiment or experience for me, inviting these people and giving them problems in the blockchain world. So this was interesting. They're wonderful people. They're highly educated. They have PhDs from very renowned universities. They have years of industrial experience. And with that, we really could pull off, for example, Sonic, and the sky is the limit for the future. So I'm very, very positive about the things which are waiting just around the corner after we have, of course, released the Sonic. Mind you, the Sonic rollout will be a very gradual rollout, so we want to really follow here some software engineering practices. So we want to first roll out only the Carmen database, and then later we will roll out the virtual machine. So we want to do the rollout in stages so that we have much control over what we are doing. Also, the rollout itself will change in the form of we have a test protocol. So what this means is test servers will run around three weeks roughly, checking that the version which will be released as the next version is good enough in two dimensions. So one is that functionally it's correct, so that the system is not crashing or not reacting badly, but also non-functionally correct in terms of it delivers the speed we want to have in terms of time to finality, transaction throughput, and disk space requirements.
From what you're telling me, testing's been huge for Fantom, and probably more so than any other chain out there from what I'm understanding. So I think you guys have nailed it in that fact that you guys have spent so much time to make sure it's perfect. Then we're going to go through another 3 weeks of vigorous testing, which is before April, I believe, anyway. So don't worry, that's not April and testing.
Yeah.
So there's more testing about to go on, and then we get this beautiful product that we all get to, sort of utilize and see the power of what's possible into the next few years, I think.
I'm very excited about these new developments in Fantom. It's really exciting, and we have many more plans which we can talk maybe in future about, and new technologies and research questions we have.
Perfect. So we've got new technology, things we can speak about, plus the rollout of what everyone's been anticipating is a huge rollout, which is Sonic for Fantom. So, if there's anything, is there anything else to add from your part, or we can wrap it up, try and keep it a little bit condensed for all the viewers, or?
Maybe we continue in a few weeks' time when the rollout is done, the first rollout, and then we can have another conversation.
why not? Maybe some live demos, things like that. So I think we can have some more conversations, as Bernard's saying. Very open to discussing with the community. I think that's great. We really appreciate your time, and I hope that everyone's learned a lot from this little interview that we've done here, and grasp what there is to be expected from Sonic, but also some of those technical points that you're probably sort of wanting to understand a little more about.
Thanks so much, Blake. Thank you.
Thank you.
Thanks.